Hi, everybody. Hope everybody's doing well. Today we're going to talk real briefly about calculating a correlation coefficient. I know we've talked already about measures of central tendency, how things, the mean, median, and mode, how that's a common measure, looking at how things group together, and measures of dispersion, how far they deviate from that measure of central tendency. But today we're going to talk about, just real briefly, correlation coefficient. Sometimes you want to look at how two variables relate with one another, how one variable affects another, or how income affects is associated with level of education. The more education you have, the more likely you are going to have a better income, right? And in criminal justice, one of the bigger factors that are highly correlated is the level of delinquency, and that's highly correlated with delinquent peer association. So the more time you spend or invest hanging out with friends that are involved in delinquency, the more likely you're going to be delinquent as well. It's a social learning variable, but it's highly relevant. All right. Now, we're just going to do a quick calculation in Excel. It's not that complex. It shouldn't be that difficult. And there's different ways to get about. But we're just going to look at the correlation value between these two variables here. And we're looking at the Pearson product moment correlation. That's sometimes called the Pearson's R. It's associated with the work of Carl Pearson, who's a common theme within a lot of the statistics. But let's calculate this. That's the correlation function. So I'm going to do open parentheses here. Now it says array 1 here. I'm going to select this column for the verbal scores. And let's see how I got A2 through A29. Then I'm going to put a comma here. Then I'm going to get array 2, the second grouping I want. Okay. And then B2 through B29, B29, B2. So close parentheses. And there you go. That's the calculation of my Pearson's product moment correlation coefficient. Now, the thing about correlation coefficients in this regard, when calculating this, it needs to be two continuous variables, and by that I mean they can't be nominal variables. That you have to use other procedures to do that. The range has to go from 0 to infinity. So height can be there. You can be either 0 inches in height, or you could be 120 inches or whatever. Or weight can be 0 to 500 pounds or infinity in theory, okay? But as far as measurement is concerned, that's important. It can't be just like a simple yes-no type of question, a 0 or a 1. Some people sometimes will apply to those types of questions, okay? There's violations to the statistical procedure by doing so, but just keep that in mind, okay, when you're looking at this. Now, the thing about correlation coefficients, they range from -1 to 1 to +1. So any value should fall within between that. If it's not, then something's wrong. Okay, you did something wrong with your calculation to some degree. But the closer you get to 1 or -1, the more highly the variables are correlated with one another. Okay, so a value of 0.9 or -0.8 is better than 0.1, okay, or 0.3 or -0.5. All right. So the closer you get to 1, the more correlated you are. The closer you are to 0, the less correlated they are. Okay, if that makes sense. So the values, the negative versus positive, it doesn't necessarily mean good or bad. So a value of -7 is more correlated than a value of 0.5, a positive value of 0.5, okay? Because you're getting closer to 1 or -1 in that sense. So you can't think of it that way. Just think of the closer you get to 1 or -1, okay? And that's your Pearson's value as well. Now, to make more intuitive sense of this, you want to square this. So this is the Pearson's R, but generally what you'll see is an R squared value, okay? And here, all you do is square this value, okay? I'm going to do that here real quick. I'm going to interpret it. So what we can see here, this, if you move, what this is essentially saying is that this value here, when squared, is your R squared value. That 53% of the variation in math is shared by verbal scores, okay? 53% of the variation in the verbal scores is shared by the math scores. So um, about half of it is shared between the two, okay, of the variation between the two. Now, um, there's there's a lot of subjectivity into this and the interpretation of this assessment, but ranges from 0.0 to 0.2 are very weak or no relationship. 0.2 to 0.4 is a weak relationship. 0.4 to 0.6 is a moderate relationship. 0.6 to 0.8 is a strong relationship, and 0.8 to 1.0 is a very strong relationship. That's kind of the guiding standard, okay, the rule of thumb for correlation coefficients. So this is basically a moderate relationship. So anything above 0.6 is considered to be a strong relationship. If you're going to get above 0.8, you're doing really well. Okay, they're highly correlated. But just because two variables are correlated does not mean that one causes the other. Okay, there might be a lot of other factors that exist that might be responsible for the value you're obtaining. Okay, the example that ice cream sales are highly correlated with crime, and there's a lot of truth to that, right? Because crime tends to increase in the summertime because kids aren't in school. There's a lot more free time. They're out and about, and a lot more opportunity to commit delinquent activities occurs. It's warmer if you live in a cold climate. If you're living in Maine in December, and you got 3-4 feet of snow, you're not out there stealing cars probably, as opposed to the summertime when it's nice, everybody's out walking about and the sun's up longer, and a lot more daylight and a lot less. Well, for kids, there's a lot less responsibility usually, and a lot less things to be involved in. So that increases crime, okay, those factors. But ice cream sales also increase in the summertime, but the two are highly correlated, right? Obviously, ice cream increases in the summertime because it's hot. People want to get ice cream. But ice cream doesn't cause crime, all right? So you got to think about these. Think about Z factors, outside variables, spurious relationships, spurious associations that might be responsible for the relationship you see. And you got to try and account for those in statistical analysis, because the failure to do so is likely to influence your results, probably in a bad way. And if you don't, somebody else will. Even here, half the variation, well, verbal scores and math scores, it could be people are spending more time being tutored or whatever. I don't know. I don't know. I can't think of anything off the top of my head as far as spurious factors for this relationship. But hopefully y'all get the gist of all that. So one more thing we can do with this is look at a quick scatter plot of the data. And that's what we're going to do. Just make a quick scatter plot. And this is a visual representation. I love visual representations. They kind of help you see what's going on here. And what's cool about this, you kind of get a trend line. So this is like the median here, okay? And that's the trend line. If you want to break it down further, you can adjust this. Let me see if I can do this. Adjust this range here so it's not so far. Maybe I can't. Let's see, axis options. So it goes to about 300 here. That's what I'm going to do. 300, and see, it makes it a little more easy to see and adjust that figure for you as well. But it's a good representation, and this would be the mean, the trend line, kind of the trend. You see a positive correlation here. That's why the number's positive for an increase from, this is how you would interpret it. An increase from 400 to 450 would increase, by that much. So you see it go right, that's an increase. It goes up, that's an increase. That's a positive relationship right there. That's a positive value, and that's correct. The way these things, we can calculate the standard deviation and see how far these values deviate from one another. Certainly the variation, it's not necessarily ideal. It's a moderate relationship, but you do what you can do, and that's not really a problem, honestly, within statistics. Being truthful is the problem, all right? Just report things honestly and forthright. People can either accept it or reject it, but that's not on to you. I mean, you're just there to report facts as investigators, scientists, and all that type of stuff. So hopefully this gets y'all going on correlations and computing the calculations and looking at the interpretations. And take care. Good luck, y'all.